A third kind of bond is known as an ionic bond. So ions are formed when you gain or lose electrons. So remember, isotopes equal a gain or loss of neutrons. An ion is the gain or loss of electrons. Be very careful with that. Students always confuse these two. Isotopes, neutrons, ions, electrons. Okay? So when an electron is lost, we actually form a positive charge. Okay? When an electron is gained, we form a negative charge. Why is that? Well, if I give an electron, so chlorine is sitting here and it's neutral, sodium is sitting here and it's neutral. But if I take this electron away from sodium and give it to chlorine, I just added a negative to it. If I add a negative, it becomes negative. If I subtract a negative from sodium, it becomes positive. Does that make sense? So when we look at these guys, we now have a positive sodium and a negative chlorine. Well, what happens when you have a positive and a negative and you put them together? They stick, right? So a positive sodium plus a negative chlorine gives you sodium chloride. What did we say sodium chloride was? Table salt. So you just made salt. Those ionic bonds are actually going to help hold all of these sodium chloride crystals together. And if you look at salt underneath a microscope, it actually has a crystalline structure, we call it. It's very structured like this, repetitive occurrences of the elements so that they are in a very fixed matrix. We don't see this with other types of compounds, but ionic compounds, we see this all the time. So we've taken and given neutrons when we talked about isotopes. We've taken and given electrons when we talked about ions. Now, the other thing that we have to briefly mention as we talk about ions or electrons is this idea of something known as free radicals. And free radicals essentially are these unpaired electrons. And in your body, they can be very, very dangerous because when we look at a free radical, it needs an electron. It is very highly reactive. It needs an electron. It's highly unstable. It's searching for an electron. And in your body, it frankly doesn't care where it gets it. So in this case, looking at nitric oxide, it has one electron right here that it would love to have. And it doesn't care where it gets it. So in your body, these free radicals will actually move around your body and steal electrons from the compounds that make you up. This is critical to think about because most of free radicals come from the environment. So things that we are exposed to, smoke, sunlight, alcohol, all of these things actually produce free radicals in our body. So we actually take and help to fix them by taking things known as antioxidants. We get many antioxidants in our food. Some of you may actually take antioxidants for some reason. Beta carotene, vitamin C and E. These are what we call free radical scavengers. They are essentially electron donators. So when we look at this interaction of free radicals and antioxidants, the antioxidants are going to supply an endless amount of electrons so that it's not stolen from our body. These are very important. Where could you get antioxidants in your diet? Blueberries? Dark chocolate? There are lots of others. Think about it.